Hello viewers, welcome to MAGESH classes. In this presentation, we are going to discuss about the questions regarding predict the major product or what is the product type of questions, and it is the reagents and the rearrangement based questions frequently asked in the JAM examination, GATE, CSR Net, TRB. It is useful for the competitive examination aspirants. Let us move into the questions part. The question one is the chemical compound is given. The three stages are provided. The products are X, Y, and Z. And what are the products? Given reagent is CH2, single bond CH, double bond CH2. The concept is when it is treated with NBS nothing, it is N-bromosuccinimide. N-bromosuccinimide involves the free radical substitution reaction. Okay, so the free radical is formed here. You get the product CHBr, CH double bond CH2. The double bond and benzene nucleus is unaltered. In case of bromine and Fe, it is the reagent for electrophilic substitution reaction. Electrophilic substitution reaction takes place in the benzene nucleus. The remaining part is unaltered. You get the product like this. That is para-bromo benzene product is formed. So it is Y and it is X. See the next one, bromine and water. It is this type involves in the nucleophilic addition reaction. So it is a nucleophilic addition reaction. Addition reaction takes place at the unsaturation. So you get the product CH2, CH, Br, CH2, Br. So this is the result. So in the reactions, various reagents are given. You have to find out the product. The concept is N-bromosuccinimide, free radical substitution. You get the product like this. It is X. And bromine and Fe, it is the electrophilic substitution reaction. Electrophilic substitution reaction takes place in the benzene nucleus. So this is the product. And it's the bromine water. The bromine is added to the double bond. It is a nucleophilic substitution reaction. Nucleophilic addition reaction. It's a type of addition. Here substitution, substitution. So the product is Z type. Okay. Next one, the product of the reaction. So the given aromatic compound is treated with the bromine and FeBr3. So what are the product? Okay, bromine and FeBr3 involves the electrophilic substitution reaction. The starting material is aromatic compound, that is CH4OH. It is treated with the bromine and one Lewis acid FeBr3. The role of FeBr3 is to abstract the electron from the electron rich species because it is electron deficient species. What you get, the FeBr3 will be converted into this CHO, and here the OH to this, the FeBr3 is involved. So here you get negative charge, here positive charge, the conversion. The CHO is the electron withdrawing group, and this Lewis base also here, Lewis acid also electron withdrawing group. So both are electron withdrawing group. When the bromine is substituted, which offers the meta position. When the electron withdrawing group is present, it offers the meta position. So the meta position is placed in CHO. The meta place is here, Br. Similarly, for this OH, the meta place is here. Okay, the product is this meta-brominated product. Answer is C. Next one, the main product obtained in the following reaction is the given compound is treated with the methyl magnesium bromide in dry ether, followed by hydrolysis. What is the product? The given compound is here this methylene group is flanked with two active carbonyl group. So it is very active. The concept is When Grignard reagent is treated with the cardinal compound, we will get either secondary alcohol or the tertiary alcohol. Similarly, this reaction is treated with methyl magnesium bromide in presence of ether. It acts as a base. Due to the presence of two cardinal group, this methylene group is acidic. So it ionizes to give bond O, CH minus C double bond O. The CH3 minus is added to the methylene part. Okay, instead of an electron, it is attached to this part. So this electron comes here, ONG Br. Okay, oxygen is added here, and here one double bond is present. Or it is with the, here the methyl group is attached. Then by means of hydrolysis, what is the product? The same reactant is repeated. Here the electron comes here and a double bond, and here one proton is acidic, it will be goes here, and methane plus Mg, Br and OH. So one H is added here, and this methyl is converted into methane. So this is the product. So the reactant is SA. Again you get. Next one is a furan. Is treated with HCl and HCN. Then H2O followed by Ag2O. What is the product? Furan is the starting material. It is treated with the HCN and HCl. It is a familiar reaction. It is nothing. It is a Gottermont reaction. Formylation reaction. It is an example of formylation reaction in presence of aluminum chloride. What you get? The product is the aldimine. It is CH double bond NH. It is treated with the water. Treated with water, it undergoes hydrolysis and byproduct is ammonia. The product is the furfural, that is CHO, aldehydic product. Then it is treated with the Ag2O. It is a mild oxidizing agent. So the furfural is oxidized to give the product the furpuric acid, this is feroic acid. Our answer is the next one, the product of the following reaction. It is the typical Cannizzaro reaction. That is benzaldehyde is treated with the NaOH. The NaOH, the OH is enriched with oxygen. So it is the basis of Cannizzaro reaction. So what is Cannizzaro reaction? The two molecules of aldehyde do not having alpha hydrogen in presence of sodium hydroxide undergoes disproportionation reaction. That is, one molecule is oxidized, you get acid, and another molecule is reduced, you get alcohol. So this is the basic. Now the question is, the NaOH consists of this OH, this 18. So the aldehyde is converted to CH2OH. This OH goes to which molecule of aldehyde? That is with the acid or with the alcohol part. So the question is, so here the alcohol does not contain enriched oxygen, the acid contain enriched oxygen. In B, the alcohol contain enriched oxygen, and in case of C, the acid contain enriched oxygen and alcohol is in the part of ONA, that is alkoxide form. And D, it is in the alkoxide form, the enriched oxygen is present. To solve this problem, you have to familiar about this Cannizzaro reaction mechanism. Cannizzaro reaction involves the hydroxylation takes place, that is C6H5CH double bond O. The base OH minus undergo the addition reaction with benzaldehyde, one of the benzaldehyde molecule, that is C6H5CH. Let us take this as a first benzaldehyde molecule. There will be O minus, here the OH is added. Then another step, this benzyl peroxide ion react with another benzaldehyde molecule. The second benzaldehyde is C6H5CH double bond O. So it is a second benzaldehyde. Here the negative species is the hydride ion from this. Okay. So what is that hydride ion? Comes, this electron goes here and this goes as hydride. This hydride will substitute here. So this benzaldehyde molecule will be C6H5CH. It will be OH. Okay. So here it is O minus, here the H is added. Okay. So it is benzyl oxide ion. Benzyl oxide ion. And this molecule will be plus C6H5C double bond O, and it is OH, benzoic acid. So here the active enriched oxygen is present. This goes to here. So this is oxygen 18, and this oxygen 18 is in the acid part. Okay, not in the alcohol part. The alcohol part does not contain oxygen. Let us discuss once again. This benzaldehyde is approached by the OH minus ion. So here it is attacked. And this OH minus ion, this is the enriched oxygen. Then the hydride is transferred. Here the hydride is transferred. So it is very important. Hydride. So it means of H minus, it is transferred. It is the second benzaldehyde molecule. Second benzaldehyde is converted into aldehyde. Okay. Sorry, alcohol. It is reduced. This O18 is not present in the alcohol part. It is present in the acid part. What is your answer now? See the answer. Here, the alcohol does not contain enriched oxygen. The acid contains enriched oxygen. So our option is A. The fifth one, the product is the phenolic ester is starting material, pH, C double bond O, and ester compound. It is treated with water enriched with oxygen 18 in the presence of acid. It is nothing, it is a ester hydrolysis. Ester hydrolysis, what is the product? Acid and alcohol. What is the acid you get? So it is acidic, it is acid of benzoic acid. So the product is benzoic acid and ethanol. Benzoic acid and ethanol, in all the cases, the benzoic and ethanol is given. The enriched oxygen is placed in the acid part. In this case, acid part as well as the alcohol part. Here the alcohol part, and the enriched oxygen is not present in the both alcohol and acid. What is the concept? The ester cleavage is acyl cleavage. Ester cleavage is acyl cleavage. So this is the concept. What is the acyl cleavage? The ester OC2H5. So this part is the your acyl part, and suppose here it is cleaved, it is the alkyl part. This is the alkyl part. So this is the acyl. The cleavage takes place in the acyl, not in this place. Okay, here alkyl cleavage is not take place. So acyl cleavage takes place. The fragment will be PHC double bond O. The water is enriched with oxygen 18, split into OH and H. So here the enriched oxygen goes to the OH minus. So the acid itself consists of this O18, and the alcohol does not contain the O18. So your answer is acid contained O18 and alcohol does not. Your answer is B. So answer is B. Okay. Next one, the major product obtained in the following reaction. Here the reagent is sulfonyl chloride. What is the product? In this product, the OH in the below the plane, and if it is treated with the SOCl2, we know that it is a substitution reaction. So in place of OH, the Cl2 will be replaced. So what is the concept? In general, the alcoholic compound is treated with ethanol. That is, alcoholic compound is treated with the vinyl chloride. What is the product you get? That is ethyl chloride plus sulfur dioxide plus HCl. So this is the concept. By means of mechanism, it is a peculiar type. It is the SNI mechanism. That is nucleophilic substitution internal. The intermediate is found here. What is the intermediate you get? C2H5O SOCl. The H and Cl is removed. This is alkyl sulfochloride. Alkyl sulfonyl chloride. So it is the intermediate. This intermediate then undergoes the internal substitution reaction. This chlorine substituted this place. Okay. So it is called internal nucleophilic substitution. That is substitution nucleophilic internal. Okay. So this is because of internal substitution reaction. The configuration is retained. So you have to remember. So it is a SNA mechanism, internal attack, and it is configuration retained. See the configuration. So in case of OH, the chlorine is substituted. You get the same retained configuration. Here the configuration is different. The hydrogen and chlorine are above the plane. So here the elimination not possible. So it is a substitution reaction. So answer A. Your answer is the correct option for the products of the following reaction. Sodamide in liquid ammonia is a reaction condition. It reacts to gives NH2 minus. When the species is the pyridine compound, it is the structure Cl. This species is an example for aromatic nucleophilic substitution reagents. The strong this NH2 base, what happens, it withdraws this hydrogen atom, and the Cl is the electron withdrawing group. So this electron goes here and this comes here. Okay, this nitrogen and chlorine is moved. So you get the special species that is called the benzene intermediate. So this is the benzene radical. Okay. So by means of this NH2 minus, the H plus is converted into NH3. Okay. Then in the presence of ammonia, liquid ammonia, the NH2 minus now substituted. It may substituted either this place or in this place. This is because the electron moves here or the electron moves here. So the substitution is in the part where it is substituted here. What do you get? If the substitution is this carbon, you get this product, that is NH2, or it is substituted the another place. What do you get? This product. So these are the mixture of product you get. Your answer is this B. That is NH2 and NH2. B or C. So in the case of B, it is not possible. So the product is NH2. C is your answer. Next one, the major product formed in the following reaction. So it is an example of Diels-Soda reaction between diene and dienophile. I have uploaded our complete video about the Diels-Soda reaction. You may go through that. Okay. So in this reaction, what is the product? The Diels-Soda reaction is always with the ento product. The favorable product is the ento one. See this? This is the diene, and your nucleophile is like the CO2, C2, CH3, CO2, CH3. What's the product you will expect? Okay, the end product is favored. The product is like this. So another bond is reacted with the carbon. So you get this COO, CH3, COO, CH3. Or this may be written like this, so bicarbon, and here the dienophile is connected, COO, CH3. Always the product is N2. The N2 and XO concept is clearly explained in the Diels-Order reaction. You should watch and clear out the concept. So what is the product now here? So it is, in this option it is given C2H5. It's a XO product, and this is your N2 product. Okay, your option is C.